Yeah. So this is Shrikant. I am a certified AWS cloud architect having 8 years of experience into DevOps along with cloud technology. So first I will show you one application, one project that how exactly we work with different teams and what exactly our role for that project. Consider I am working on one of the retail project. Let's say Amazon.com. Yes. So my client is Amazon. This project which involves with the different teams. Here we need to understand what exactly your role for this application as a DevOps engineer. This is application front end. It has many features and number of products are available here. Regularly we need to work with different teams. I would say development team, DevOps team, tested team, and production team. Here, the responsibility of a development team is develop the code. That means they write the code in any language. I can say Java, Python, either C, C++, PHP, whatever it may be. The next team is DevOps. Our responsibility is build, deployment, and automation. Build is nothing but create in the package. That means in the format of .zip, .tar, .var, .jar, whatever it may be. It depends upon the backend code which was developed by the development team. Let me show you one thing how exactly the build will work. So let's desktop. So I have this folder, latest software. So it has many folders and many files. So I can extract it as a zip file. Let me compress to zip file. Yes. So this is the file we have. That means we are compiling it and making it as one file in the format of zip. In the same way, if the developer write the code, suppose if the developer write 500 lines of code, every time we cannot take the code and deploy into the servers. That is the reason we build it as a package like .zip, .jar, and we deploy into the servers. That is what build. And next thing is deployment. Deployment is nothing but install in the package. That means whatever we build the package, we need to install in the servers. Finally, we need to install in one location that is called a server. Sometimes, for example, sometimes we get an update. If we go here, if there is any update, we can see the download option, but we cannot see the backend code. If we click on download symbols, it just download it. That means it can install the latest updates. So like that, as a DevOps engineer, we need to install the package into many servers. I would say my client came to me and saying like we need to deploy the package in different environments. So in every organization we maintain some environments. This is client will suggest what are the environments we need to use for the particular project. Let's say dev environment we have 20 servers, integration we have 10 servers, staging we have 15 servers, and production we have 35 servers. So once the build is done, like create the package, that package we need to deploy into different servers. So in the 20 servers we need to perform the deployment action. That means we need to install the package in 20 servers as a dev environment. Okay, so this is what build and deployment. And next thing is automation. The work which we are doing manually, we wanted to automate it. So every day we cannot create the package manually and we cannot deploy. So it's a time taken. That's the reason automation came to the picture. So once it is deployed by the DevOps engineer, then the testing team will do some test regarding the functionality. We call them as validation team. Once it is validated, then it will get into the production. It's a live environment. That means release in the future to end user. End user means customers. We are the customers. So for example, I have a requirement. That means I need to send a picture from one person to another person through WhatsApp. That feature I wanted to implement. So this is actually requirement. So initially the developer develop the code. That means they write the code for this new feature. Once the developer develop the code, as a DevOps engineer, our responsibility is take the code from the developer, build a package, and deploy into the different servers. Once it is deployed, then testing team will perform the validation checks. Then it get released into the production for the end users. This is how the flow will be. As a DevOps engineer, you need to work with different platforms, DevOps tools, infrastructure as a code, infrastructure as a service. What exactly we are doing with DevOps tools? What exactly we are doing with infrastructure as a code? What exactly we are going to do with infrastructure as a service? The complete thing, one word answer is development and operations. That is what DevOps. It's DevOps, it's a combination of development and operations. So, before DevOps, how it was, why DevOps became so popular in the market, you need to understand this. So, before DevOps, generally software development happens in two phases. One is development and second one is operations. So let us say my project is Coles.com. This is retail application. So I need sign in, sign up option here in the front page. So for this new feature, the developers first plan for it and they write the code and they build the code and they test. So once these done, then it will send to the operation team. Operation team will perform the deploy and test. So once testing and implementation of whatever is developed by the developer, then operation team send the feedback to the DevOps team. That means there is no mutual coordination between development and operations. So here the development team should wait until they get the feedback from operation team. That means this is extended the timeline and delayed the entire software development cycle because of no proper coordination between the teams. If we continuously provide the feedback to the developers, the project will be closed within the timeline. That's the reason DevOps came to the market. If you see the DevOps diagram, yes. So this is the DevOps diagram. It it indicates infinity sign. That means continuously happens. Continuous development, continuous build, continuous deployment. That means through we have some tools through that we perform automation. So that is the reason every company expect the candidate having experience in DevOps with cloud technology. So we have different tools in the market to automate the process. Let's say first thing, Git. It is a source code management. That means version control system. For example, we have 50 people in the development. They develop and write the code. End of the day, they have to keep in one location. That location is Git. It is centralized repository. Repository means in the sense of folder where we store our code. So here we maintain some versioning. It is related either related to new feature or fixing the existing code bugs. So this is what Git. And then Maven. Maven, we perform build by using Maven. So as a DevOps engineer, we should be take care of build. So build we can do it by Maven. So as a DevOps engineer, we take the code from the developer and then we build it as a package in the format of .jar, .var, .year, whatever it may be. And then Jenkins, most important tool. It is a continuous integration tool where we integrate our source code. Integration is nothing but combined in the source code. For example, we have 500 developers. They develop the code. Finally, we have to integrate the code. So, before integration, how it was, you need to understand. Suppose I have to add a new feature, as said earlier, login, sign in, sign up option in the front page. So, they given the deadline is next month end. The developer write the code until 28th next month for the new feature. As a DevOps engineer, while compiling, building a package, we get number of issues in the code. It takes 3 days time to fix the issue. So the timeline is over, but the code is still under bug fix, but not yet too ready. So this is bad impression to the entire team and project. That is the reason integration came to the picture. Through this continuous integration as a Jenkins, continuously integration happen. Continuously code fix happens. That means whenever the developer write the code and push to Git repository, the CA tool will collect the changes and automatically perform the deployment action. And then Nexus. It is a backup artifactory which is used to store artifacts. That means our files, packages, we store in the Nexus. It is a central repository. Suppose if somebody joined newly, by mistake he deleted the code which was developed by the developer. Then we would get it from the backup repository. It's a backup registry. And then come to the Docker. It is a containerization tool where we can store our microservices in the form of containers. and then Kubernetes. So these are all most important. Kubernetes is a container orchestration tool where we deploy our application as a cluster. It has a mechanism of cluster where we run the application as a pods in the node, and it has some load balancing capacity and it has some auto scaling capacity, so it can make our application is always up and running without any downtime. And we use Ansible as a deployment tool. We use it to deploy in multiple servers. Let's say we need to install Java in 50 servers, so through Ansible we can do it in a single shot. And then Terraform, it's the infrastructure as a code used to provision the infrastructure in any cloud. And then ELK is monitoring our application, and Jira is a ticketing tool uh, which is used to track our task. It is a it will give mutual coordination between DevOps and development team. That means to manage work between developer and DevOps, we use a Jira ticket. It is a ticketing tool. For example, one of the client came and asking like, "Hey Srikant, I have a project. Do we implement the DevOps methodology for this?" I would say yes. I can give some suggestions. First, I use cloud. I can use storage, I can give access, networking, DNS, cluster, monitoring, ticketing system. So these are all services which are available in the cloud. We do not worry about the license. The client will purchase the license, and they can give us. So AWS people will charge hourly basis, and end of the month you have to pay. So this entirely take care of client. So as a DevOps engineer, your responsibility should be decrease the money for your project as much as possible. Because of this, we need to use some open source tools. Open source means no need to pay single rupee as well. The DevOps tools I discussed earlier, some of them are available in open source. That is the reason all the companies looking for the candidates who has knowledge in DevOps tools with cloud technology. So here you need to understand DevOps is nothing but combination of tools. AWS is nothing but combination of services. So before cloud, how it was? For example, this is my Windows laptop. So I want Linux. I want Ubuntu operating system. I can install it, but I cannot work parallelly with all OS at a time. So until unless I stop other OS, I cannot use it. But in the cloud AWS, whatever OS you need, you can get it within minutes. You can get Linux, you can get Ubuntu, you can get CentOS, you can get Windows, whatever it may be, you can get within minutes. So before cloud AWS, how it was? So let us take, for example, we have on-premises. That means physical machines. We operate them physically. How these physical machines work, you need to understand here. So, for example, before Tata Sky and Airtel came to the market, how exactly broadcasting the televisions? That means broadcasting will happen from one location. Your receiver receive the signals in another location. Suppose if we lost the power, the entire team, let us take for example a village, the entire village will suffer. But in the cloud, if one server went down, then another server automatically get the signals. And also in terms of security, AWS has more. That is why AWS cloud became so popular in the market. So in the AWS, we use very limited services like IAM, EC2, S3, VPC, CloudWatch. Okay, let me show you front end of AWS. So this is AWS. So we have many services. So no need as a DevOps engineer, no need all these services. We just need a very limited services. Okay, where like I mentioned here IAM it's for access related things, and this is virtual machines, this is bucketing system, this is networking system, this is logs monitoring, this is endpoint uh, usage, this is database data we can store the data, this is encryption of our secrets keys. This we can manage our secrets. So these services are enough in the AWS cloud. Okay, so after that, in our training, we do some real-time projects, which includes CI/CD pipelines. Uh, we use some of the services in our project. For let me show you. So we are going to build the Java code. We do not write the Java code here. Just we take it from the developers and we push it as into the Git, and then we build the code using Maven and Jenkins. And also we use JUnit test cases, and it get released through Jenkins, and we use Ansible as a deployment tool. It get deployed into the AWS, and we are going to use the containerization tools Docker and Kubernetes. We are going to introduce Nexus as a artifact repository, and SonarCube is for quality analysis to monitor our code. And also we use Nagios or ELK to monitor our infrastructure. So these are the services which we are going to use in our training. Let us consider initially we are starting off with a simple CI/CD pipelines. That means continuous integration, continuous deployment. So we need to understand the flow here. The developer commit the code to Git, and then we integrate Jenkins there, build and test will happen, and finally get into deploy into the EC2 instance. So once you are comfortable with this, we will introduce Ansible. We'll create a few playbooks, and through Ansible we are going to deploy. Here we wanted to install Apache Web Application Server. For that we are going to use the Ansible playbook as the jar file deployment through the playbooks. So once you are comfortable with this, we will introduce the Nexus as a artifactory to store the artifacts. So this time Ansible can communicate with the Nexus, takes the artifact and deploy into the EC2. Then we will introduce SonarCube. SonarCube generally will review your code and give some static analysis, which is helpful for your developers. Then we introduce Docker as a containerization tool. This time we deploy into the containers by creating the Docker file and Docker images. So once it is working properly, then we'll introduce Kubernetes. Kubernetes will create a Kubernetes cluster, by using the Docker images, we'll deploy the pods. So after doing all the activity, we are going to monitor our infrastructure through Nagios. So this is how we are going to set up a production ready CI/CD pipeline. So I am going to share my knowledge through the real-time projects. So I am going to do this activity in our training. Thank you.